Derivatives of inverse trigonometric functions. Inverse trigonometric functions, this is a new word for you. There is one chapter for you students called as a inverse trigonometric functions. So that chapter we learn in detail later. Now what things we are required here, those I'll highlight. You heard trigonometric functions word in first PUC. Now we have reverse of that, that is what we call it as a inverse trigonometric functions. Now before going to start derivatives of inverse trigonometric functions, first I'll tell you regarding what these inverse trigonometric functions we have. Suppose I'm having a set A and another set B. In set A we have the elements 1, 2, 3. In set B we have the elements A, B and C. Now suppose f is a function now from set A to set B, where 1 is related to A, 2 is related to B and 3 is related to C. Now here in this function you can see the domain is set A with the elements 1, 2 and 3. So these all are the different elements we have. And when you see their image is here, one image is A, 2's image is B and 3's image is C. Means all these elements of the domain, that is different elements of this domain, are having here different images. Similarly, all the elements of this codomain are having pre-image. A is having pre-image 1, B is having pre-image 2, C is having pre-image 3. Means here different elements have different images, as well as all the elements of this codomain are having pre-images, and hence here what we call is the function is bijective. Bijective function means the function which is 1, 1 and onto both. 1, 1 means different elements have different image, and onto means all the elements of codomain must have pre-image. Now whenever this function is bijective students, we say that inverse of this function f exists, and that inverse is nothing but we write symbolically as f inverse. We write symbolically as f inverse, and it is a function from B to A will get. See here 1 is related to A, means in f inverse function A is related to 1 you will get. I'll show you here. F inverse is a function from where to where you are getting. This is f inverse function. It is from B to A. In f I said that 1 is related to A. Here you will get A is related to 1. B is related to 2. C is related to 3. Yes, it is also a function we have. So what we can say, whenever the function f is bijective, f inverse exists. And what is bijective means? Function should be 1, 1 as well as onto. Now this is what inverse of a function. Remember, whenever the function f is bijective, then only f inverse exists. And when f is a function from A to B, we write f inverse is a function from B to A. And one more thing here. Suppose you have the element x here and y. Under the function f, if x is related to y, we write f of x is equal to y. Now when f of x is equal to y, then in inverse what you will get? F inverse y is related to x you are getting under the function, that is f inverse. And in that case we write f inverse of y is equal to what? X. So remember, if f of x is equal to y, then what we can say? F inverse of y means this f, when you bring to the right hand side, it becomes f inverse. F inverse of y is equal to what you will get? X. So both the way it holds good. When f of x is equal to y, I'll bring this f to the right hand side, it becomes f inverse of y. Or if you are having f inverse of y is equal to x, then y is equal to, bring f inverse to the right hand side, it becomes f of x. Means when you take f to the right hand side, it becomes f inverse, and when you take f inverse to the right hand side or left hand side, it becomes f. This is another thing you should remember. This is what inverse of a function. Now come to the trigonometric functions. Total you learnt 6 trigonometric functions in PUC first year. So the number 1 we have, that is sine function. In short we write that is sine theta or sine x and all. Now here you learnt in first PUC that sine is a function from, that is what, set of real numbers to, that is closed interval minus 1 comma 1. All the values of sine starts from minus 1 and ends with plus 1. Even you learn that value table, I'll show you. Here I'll take, suppose this is what the value table I'm having. Here I'll take this as a x belongs to the domain and sin x value belongs to the codomain. Suppose you have here 0, pi by 6, pi by 3, 60 degree, pi by 2, pi and so on. This side minus pi, minus 2 pi and so on. Some values I have taken. What is sine 0? 0. Sine 60 degree 1 by 2. This is sine 30 degrees 1 by 2. Sine 60 degree root 3 by 2. Sine 90 degree 1. Sine pi is 0. Sine minus pi is also how much? 0. Even sine of minus 2 pi is also 0 we have. Multiple of pi, sine value is 0 we are having. Now here we'll see what about, is it the function sine is 1 1 and onto or not, because function sine inverse exists only when function is bijective. Now let us see 1 1 first. Now listen, in the domain there is a element 0 and there is another element, that is pi. 0 is having image 0 here, and pi is also having image as what? 0. So what happened here? 0 and pi, these are the different elements, but what about their image we have here? That is same we have. So different elements have same image, means function is not what? Function is not 1 1 here. So what happened? Sine function is actually not 1 1. So what is our duty here is, first you should make this function as a 1 1. So that's why what is your duty here is, you should restrict the domain now, means from where to where I have to take the elements such that function is 1 1 as well as onto. So for that purpose what they do here, suppose I'll take, instead of minus 5, suppose here minus pi by 2, then what this value we will get here? This value becomes, that is minus 1. Now you see, restriction means from where I can do. Here minus 1, 0, 1 by 2, 3 by 2, when you see these values up to here all values are different. So I'll restrict this entire set as only up to this. Now what happened? Now just you remove this entire thing, whatever you have. Now only you concentrate here in this. So what you will get? Tell me what you are getting here. When you see only this part, whatever I have marked here, minus pi by 2 is having image as minus 1, 0 is having image as 0, pi by 6 is having image as 1 by 2, pi by 3 is having image as root 3 by 2, and pi by 2 is having image as 1. So all these different elements have different images here in the codomain, means function is what? 1 1. And even all the elements of this codomain are having pre-image here above, you can see. So the function is even onto also, means this function is 1 1 and onto when I have taken from minus pi by 2 to plus pi by 2. In that case function is bijective you got. So what I can write now, sine is a function from when I take minus pi by 2 to plus pi by 2. Range is what we have, all values are covered there, minus 1 to 1. In this function is what we have, bijective. I have restricted the domain only to, that is my, in the beginning I said that sine is a function from R to this. But now instead of taking R, I have restricted the domain from minus 90 degree to plus 90 degree. Only in this case, function is what we have, bijective. And when function is bijective, inverse of the sine function exists. And how we write? Here I'll show you. See how we write. That is, whenever f is a function, we write f inverse. Now sine is a function, then we write symbolically sine inverse, and it is a function from reverse you will get, that is closed interval minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2. So we say that sine inverse is having domain closed interval minus 1 comma 1 and range, that is closed interval minus pi by 2 comma pi by 2. Thus sine inverse function we got. This is what we call inverse. This is one of the inverse trigonometric function, and that is what sine inverse. Remember, sine inverse domain is closed interval minus 1 comma 1 and range is minus pi by 2 to plus pi by 2. So like this we got 6 inverse trigonometric functions with different domain and range. So those you will study in detail in the chapter inverse trigonometric functions. So just now you remember how you got these, that is inverse trigonometric functions, and even some properties we need while solving the examples that we discuss later. This is regarding, that is inverse trigonometric functions. Now let us move to the, that is how to find the derivatives of these 6 inverse trigonometric functions. So what are the 6 inverse trigonometric functions we can write now? Number 1, that is sine inverse. Next, cos inverse, tan inverse. See, all are having different domain and range depending on how the function becomes bijective. I have told for sine inverse, no, like that we should verify for remaining all. Tan inverse, cot inverse, sec inverse, and one more is cosec inverse. So here in this concept, first we study how to find the derivatives of these 6 inverse trigonometric functions. Let us begin with the first one, the derivative of sine inverse x with respect to x. First I'll take, let y is equal to sine inverse x for all x belongs to closed interval minus 1 comma 1. So domain of this sine inverse x is closed interval minus 1 comma 1 we have. Now what I do here, first I'll take this sine inverse to the left hand side, it becomes sine. So you will get sine y is equal to what? Is equal to x. Now differentiating with respect to x. Sin y differentiation with respect to x means what we write? Sin differentiation is cos. So I'll write cos y into y differentiation with respect to x means dy by dx is equal to differentiation of x with respect to x is 1 you will get. So what is answer? Dy by dx is equal to 1 divided by cos y. Now this is equal to 1 divided by, see, we know here that is sin y is nothing but what? X. The x value we are having as a sin y, and here we got the derivative in terms of what? Cos y. So here I'll make use of trigonometric identity. You learned sin square theta plus cos square theta is equal to 1. Then from this, what you are getting? Cos square theta 1 minus sin square theta. So cos theta will be, that is root of 1 minus sin square theta. So here cos y is there. Cos y means I'll write root of 1 minus sin square y. Root of 1 minus sin square y. Now this is equal to 1 divided by root of 1 minus. Sin y is nothing but what we are having? X. Sin square is there, so I'll write x square. So this is dy by dx. That is nothing but d by dx of y, and that y is nothing but what we have taken in the beginning, sin inverse x. d by dx of sin inverse x is equal to 1 divided by root of 1 minus x square. So remember, differentiation of sin inverse x is 1 divided by root of 1 minus x square. This is the first, that is derivative of sin inverse x. Now second one, derivative of cos inverse x with respect to x. First, I'll take let y is equal to cos inverse x for all x belongs to closed interval minus 1 comma 1. The domain of cos inverse x is closed interval minus 1 comma 1 we have. Now, same duty again, procedure is same what you did for the previous example. Cos inverse you bring to the left hand side, it becomes cos. Cos y is equal to x. Differentiating with respect to x. So first, cos differentiation is minus sin y into y differentiation is how much? Dy by dx is equal to differentiation of x with respect to x is 1. So what you will get? Dy by dx is equal to 1 divided by, bring this term to the right hand side, it comes to the denominator, you will get minus sin y. So I'll write this as a dy by dx is equal to minus, I'll take the numerator means minus 1 divided by, here sin y is there and we know here cos y value. So I'll replace this sin in terms of again that is cos. Just previous how we did know by using trigonometric identity, sin y means I'll write root of 1 minus cos square y. Now this is minus 1 divided by root of 1 minus, what is cos y value? X. Here cos square is there, so I'll write x square. So this is what differentiation of, that is cos inverse x. So how we write? That is differentiation, that is d by dx of cos inverse x is how much? Minus 1 divided by root of 1 minus x square. This is the second, that is derivative of cos inverse x. Now move to the third, that is derivative of tan inverse x. Let y is equal to tan inverse x for all x belongs to R. The domain of tan inverse we are having, that is set of real numbers. Again same, bring tan inverse to the left hand side. It becomes tan, you will get tan y is equal to x. Now differentiating with respect to x. What is differentiation of tan we have? That is x square. So x square y I'll write into y differentiation will be, that is dy by dx. And x differentiation is how much we are having? 1. So dy by dx is equal to 1 divided by, what you will get? X square y. Now here we know the value of tan y, how much we are having? X, and we got here derivative in the form of x square. So I'll write this x square y value in terms of tan. There is again one other identity you learnt in first PUC, 1 plus tan square theta is equal to what? Sec square theta. So what I can write? Sec square y means 1 plus tan square y. Now this is equal to 1 divided by 1 plus, what is tan y means we have? X. So tan square y is there. So I'll write x square. So what we got? It is differentiation of tan inverse x with respect to x is how much? 1 divided by 1 plus x square. This is, that is third one, differentiation of tan inverse x. Now next, move to the next one, that is fourth, the derivative of, that is cot inverse x with respect to x. So here I'll take again first y is equal to cot inverse x. Bring cot inverse to the left hand side, it becomes cot, you will get cot y is equal to x. Differentiating this with respect to x. What is differentiation of cot we have? Minus cosec square y into y's differentiation will be dy by dx, and differentiation of x with respect to x is 1. Now this is dy by dx is equal to bring this term to the right hand side. I'll write minus in the numerator, minus 1 divided by how much you will get? Cosec square y. Now this is minus 1 divided by, we know the value of cot here, so I'll write again cosec in the form of cot by using the identity 1 plus cot square theta is equal to what? Cosec square theta. So 1 plus cot square, it is in the form of y we have, so I'll write 1 plus cot square y. Now this is minus 1 divided by 1 plus cot y is nothing but x, so I'll write this is x square. So what we got here? Differentiation of, that is differentiation of cot inverse x with respect to x is minus 1 divided by 1 plus x square. This is the, that is fourth formula you should remember. Derivative of cot inverse x with respect to x is minus 1 divided by 1 plus x square. Now move to the fifth one. The derivative of sec inverse x with respect to x. Let y is equal to sec inverse x for all x belongs to. The domain of sec inverse is all real numbers except the real numbers in between minus 1 and 1. So we write for all x belongs to r minus open interval minus 1 comma 1. Again bring this sec inverse to the left hand side. It will be sec y is equal to x. Differentiating with respect to x. Sec differentiation is what we are having? Sec x if it is there. Differentiation is sec x into tan x. So I'll write now sec y into tan y into what you should write? Dy by dx, because we are differentiating with respect to x, is equal to differentiation of x with respect to x is 1. So dy by dx is equal to what you will get? 1. These two terms you bring to the right hand side, it comes to the denominator. You will get sec y into tan y. Now this is equal to 1 divided by sec y into, see we know here sec y value, that is x. Here we are having tan, so this I'll replace this tan now in the form of sec again by using the same identity, that is 1 plus tan square theta is equal to sec square theta. So from this what you will get? Tan theta. Tan square theta means it is sec square theta minus 1. So tan theta means you will get root of sec square theta minus 1. Means here I'll write root of sec square y minus 1. Now this is equal to 1 divided by what sec y means we have? X. X into root of x square minus 1. This is what differentiation of sec inverse x with respect to x, and that is how much? 1 divided by x into root of x square minus 1. Next, last one, sixth inverse trigonometric function, that is cosec inverse x. We find the derivative of this cosec inverse x with respect to x. Again same duty, I'll take this cosec inverse x means y. Now bring this cosec inverse to the left hand side, it becomes cosec. Cosec y is equal to what? X. Now differentiating with respect to x, what you will get? Cosec differentiation is minus cosec y into cot y into what you should write? Dy by dx is equal to differentiation of x is 1. Now dy by dx is equal to 1 divided by minus of, that minus I'll write here, cosec y into cot y. Now this is equal to minus 1 divided by cosec y, I'll write as it is. Cot y means cot, I'll write in the form of cosec, just how we did for the previous one. This is nothing but root of what you will get? Cosec square y minus 1. So now minus 1 divided by What is cosec y means? We have x, so we will get x into root of, that is x square minus 1. This is the differentiation of, that is cosec inverse x. So I'll write d by dx of cosec inverse x is minus 1 divided by x into root of x square minus 1. This is the, that is sixth formula you should remember. So here I have written all the 6 formulas. I'll just read once. D by dx of differentiation of sine inverse x with respect to x is how much? 1 divided by root of 1 minus x square. Differentiation of cos inverse x with respect to x is minus 1 divided by root of 1 minus x square. So when you see these two formulas here, that is derivative of sine inverse and cos inverse, only there is a change of minus. Sine inverse x differentiation is 1 divided by root of 1 minus x square, and differentiation of cos inverse x is minus 1 divided by root of 1 minus x square. So very easy to remember here, only the change of, that is minus we have. Similarly, differentiation of tan inverse x with respect to x is 1 divided by 1 plus x square, and differentiation of cot inverse x is minus 1 divided by 1 plus x square. So again change is of minus here. Next, differentiation of sec inverse x is 1 divided by x into root of x square minus 1, and differentiation of cosec inverse x is minus 1 divided by x into root of x square minus 1. If you know sine inverse x differentiation, same you should write for cos inverse with minus sign. Differentiation of tan inverse x, same with minus sign you should write for cot inverse. Like this you should find all the derivatives of 6 inverse trigonometric functions. So after writing all the 6 derivatives, you write this remember sheet. Examples we do in the next class. Thank you.